All right, so student, this question is again from friction, but this time what you have is the involvement of a spring here. You can read the question first, and then I will explain how do we solve this. Okay, let's do it together. Okay, let's say, so you can see in the question you have a block, okay, which is given to you, and this block starts with a velocity of 3 meter per second, and the distance AB is 2 meters. The distance BD is 2.14 meters, and the distance DC is 1 meter. It's given the length of the spring is 1 meter. The spring constant is known to you. The frictional constant from B to C. There are two frictional constants, coefficient of frictions, which are given to you. I think they're given to be 0.22 as the static friction, and the kinetic friction is zero point 0.2. Okay. The question is, and you can see some dark surfaces, right, where the friction exists. So let's see what are those surfaces. So uh, the surface which has no darkness, right? If you see the surface at which the block is there, has some part at AB has no friction, and B to C there is friction. The question is, this block, how much distance will it move before it comes to stop? What's a distance? Okay, I've drawn the situation which I was reading. So let's try and do this. So when I look into this question, obviously, I have a sense that we are talking about we are giving some 3 meter per second velocity to this. It is 0.5. That means we're putting this to motion, right? So obviously we are providing it some uh, kinetic energy, right? So the kinetic energy it starts with is half m, it is zero point 0.5 into 3 squared. So this becomes your 4.5 divided by 2 is equal to 2.25 joules. You start with this. And then you move through a distance of 2 meters. AB, you are frictionless. Okay, so AB is frictionless, right? So no dissipation, no dissipation, right? There is no non-conservative force here. Conservative force would have friction is a non-conservative force, and if you move through a frictional surface, you are going to lose your kinetic energy, right? So read about the concept of non-conservative, right? Non-conservative sucks energy from you, right? It takes away the energy from you, and which is not the case in this AB part. Let's move through BD. Okay, so BD, you will start losing energy. Okay, and let's see how much energy will you lose. So you enter here at a velocity of 3 meter per second. So at B, your velocity is 3. You have to move through 2.14, right? Let's see if you move through 2.14, what exactly is the work you have to do against the friction. So the friction which is getting acted through BD is going to be, since it is in motion, we will select mu K M G, right? So it is 0.2 multiplied by half into 10. So this is 5 into zero point 0.2 is equal to 1 Newton. So 1 Newton is the frictional force through BD. Now, when you move a distance of 2.14, right, what is the loss against the friction? So the work done against friction is 1 into 2.14, right, which is negative because it's a non-conservative. The friction is reducing your kinetic energy. So this is minus 2.14 joules. Okay. And so the balance energy at the point D, you have a balance energy at point D, right? So the remaining energy you have is 2.25, which is your kinetic energy, and minus 2.14. So you're left with only, let's say, 0.09 joule of energy. at the point D. So you've reached the point D, but you're only left with 0.09 joule. You started with 2.25, you lost against the friction energy of 2.14. We have used the coefficient of, okay, 2.14 is a displacement, this is the mass, okay, so sorry, the friction multiplied by the distance. So this is your F multiplied by displacement. The angle is 180 degree, hence the minus sign. Okay, and it's a non-conservative field. So from there also the sign is negative. Now your balanced kinetic energy is only 0.09 at the point D. Right? So you are at a point D and you are at 0.09 joules. Now what happens? You start moving forward, and at a certain place you are bound to stop, right? But something else is going to happen. D onwards you still have friction, right? So this place also has friction. You still have friction, right? So as you move forward and you start pressing the spring, then you stop. Okay, what is happening? Your energy, which is 0.09, is being used and consumed where? In two forms. So 0.09, which is your balance energy here, will get used in half kx square, right? Law of conservation of energy. The total energy you're left with gets used in the spring energy of kx square. I hope you understand this concept pretty well. Hooke's law derivation should be understood. Half kx squared, the potential energy stored in the spring, when this block comes to a standstill. Say it comes to standstill here. Okay, so this is another distance of x you moved through. And through this distance of x, you have also lost the energy against the friction. How much friction is here? We've already calculated. This surface has a frictional force being offered as 1 Newton throughout from B to D. Sorry, B to D and D to C is all friction. So, plus you are going to spend some energy in 1 Newton friction multiplied by x. Okay, looks like a quadratic equation which is coming up. So this is 0.09 is equal to, your spring constant is 2. So let's put it as 2. So you will get x squared plus x, right? Okay, so here is your, so to say, the quadratic. Let's solve the quadratic equation. X squared plus x minus 0.09 is equal to 0. X is equal to minus 1 plus minus b square minus 4 into 1 into 0.09 divided by 2 is equal to minus 1 plus minus. This is 1 plus 0.36 divided by 2 is equal to minus 1 plus minus under root of 1.36 divided by 2. Now, under root of 1.36, 1.2 square is 1.44 and 1.11 is 1.21, right? So 1.1 square is 1.21 and 1.2 square is 1.44. So you can see this is pretty close to 1.2, 1.36. So let's say this, I call it, it's minus 1 plus minus 1.18 maybe, right? Somewhere. It's a approximation technique, right? So I will not use the minus sign, because if I use the minus sign, my whole x will become negative, which is not possible. I have moved through some distance. Divided by 2 is equal to 0.18 divided by 2 is equal to roughly 0.09 meters. I'm not sure the total distance it moved through before stopping. It moved by 2 meters. Okay. So you have 2 meters. Then it moved through 2.14, and then it moved through another 0.09, right, which is this part of it. 0.09. So the total distance it has moved is around 4.23 meters. Okay, the closest answer we have got is all right, C. C. So the correct answer is C. I hope you like this video. Please don't forget to subscribe to this channel because you're going to get some beautiful, fantastic explanation of physics. I just don't solve. I'm giving you the details which will help you become strong in your concept, and the retention will become very, very high. Thank you again.